Hi everyone, here we're going to go over a basic theory for today's lab, the density lab. It's a pretty simple lab, and really what it's meant to is for more exercise on error analysis. So this is an extension of the error analysis lab. So the theory for today is that let's see here, you're going to have a graduated cylinder that's going to have some liquid, and this thing is going to be used to measure volume. V, that's going to represent the volume. And you're also going to have a digital mass scale. And you're going to have different materials. So let's say that you're going to have a piece of gold. And you're going to weigh the gold, and you're going to measure the mass of gold. And then you're going to take the gold and so first off, you're going to measure the mass of gold, and the next thing is when you measure, you're going to dip this piece of gold into this liquid, which is going to be water. And when you dip the gold into the water level is going to rise. And by measuring the height, that the volume that the water level increases by, that's going to correspond to the volume of gold. So if you're going to have a series of materials, and for each material you're going to measure their masses and also their volumes. And then after that you're going to calculate the density of the materials. So the density of the materials is going to be the mass of the object divided by their volume. The only thing that you have to be careful of is that the mass should be in kilograms and the volume should be in cubic meters. So make sure that you convert to kilograms per cubic meters. So make sure these masses are in kilograms, and make sure these volumes you convert them to cubic meters. And this is going to be your experimental density. And after that, what you'll do is you're going to just look up on a table the accepted densities for each of these materials. And you'll calculate a percent error for these materials, and a percent error is going to be defined as the absolute value of the experimental density minus the accepted density and divided by the accepted density again times 100. So this is a pretty simple lab. The main thing is to make sure that you convert your units properly, and that you record the error of this mass scale and the error for the volume. Let me say one thing here about these errors. For both of these things, take the mass scale to be a digital reading. So when you record the error, take it to record the error for a digital device, and also for the volume, take the volume also to be a digital reading. And you'll have to use the error analysis lecture to see how to read the errors for digital devices. And I believe for both of those also, there's going to be no fluctuation in the readings. And the final part is just to calculate so this is your value for density, and there's an accepted value, so you want to see how accurate your experiment was. So you're also going to calculate the error for your density. So the error in the density is going to be defined like this. It's going to be the experimental density that you calculated previously and multiplied by this factor. And the factor is going to be the square root of the error in the mass divided by the mass, and this gets squared, and then plus the error in the volume divided by the volume, and that gets squared. And that'll be the final calculation for the density lab. So the density lab was pretty simple. It was just a verification of density is equal to mass over volume. And the purpose of this lab was really more for you to get more experience with error analysis and for using Microsoft Excel. So this completes the instructions for the density lab. So good luck, and if you have any questions, go ahead and let me know.